Welcome to another episode of Head First with Dr. Hill. Today's guest is Daniel Schmachtenberger, who is a co-founder and R&D director of the Neurohacker Collective, which sounds kind of exciting. So Daniel's going to tell us all kinds of cool things today and dig into his history a little bit and some of the projects he's working on. So welcome to the show today, Daniel.
Thanks for having me. It's fun to be here with you.
Yeah, happy to have you. So first of all, what is this collective of neurohackers you are assembling? It sounds like a sort of pie in the sky, big project where you're aiming for a lot of world-changing goals. But can you unpack a little bit for us what your approach here?
Yeah, so by neurohacking, we mean anything that can optimize the mind-brain interface and the function thereof. So this is cognitive and psycho-emotional and health and well-being. And so we could roughly define it as well-being optimization, but even larger than that, we think of it as sovereignty optimization. People's capacity to make good choices, right? To be adaptive, which is a function of intelligence, of agency, of sentience all together. And there's obviously kind of human software, right? Psychology involved, and there's human hardware, physiology involved. And we know that the software-hardware divide in humans is a plastic one, right? It's continuously interaffecting each other. And so, your work with neurofeedback is neurohacking. The other people you've had on the show discussing meditation, et cetera, is all in that space. So we're interested in all categories of technologies that can meaningfully increase the homeostatic capacity, the homeodynamics, as you like to call them, of the human neuroregulatory system, and thereby increase people's capacity for complex thinking, emotional resilience, etc. And the reason why collective is anyone that is doing meaningful work here, we want to figure out how we can participate at a research level and at a information product level, etc. So like us talking here together is awesome, co-sharing information in the space. That's great.
So you say sovereignty. It's an interesting way to frame that.
Yeah.
Agency. What do you mean by? I mean, what kinds of things are bottlenecks to human agency that appear to be affected by things we can do to the brain? Like how can we affect agency in tractable ways? What are you seeing? What are you exploring?
Yeah. So by agency here, we mean the actuator capacity of a complex system, the ability to act on and in the world.
Okay.
Right? Sentience is kind of roughly related to our sensory input capacity, intelligence to our information processing of that sensory input, so that those exist in a closed loop. Take in information about the world, which is internal and external sensing, process it to inform choice, make choice, get data about that choice, recursively upregulate. And so on the agency side, on the capacity to act, obviously that requires the capacity to have good information and information processing, so there's good choice informing it, right? It also requires impulse control, so that one can actually have executive function and all that they know come to bear. It also requires kind of choice-making side of it, requires the capacity to think through things using different frameworks, right? Critical thinking frameworks, systemic thinking frameworks, lateral thinking, etc. But also on the agency side, emotional resilience is a key factor, so that as one is working with things and difficulties come, they can process that physiologically and psychologically in ways that empower them to continue to learn rather than get shut down. And so when we look at the physiology of that, we know a lot about how dopamine, about how adrenal hormones, about how many different aspects of neurochemistry and physiology are involved in one sense of drive, one sense of reward dynamics that can predispose dysfunctional or more functional patterns of human behavior, increased sense of capacity psychologically, physiologically, etc.
So again, we're back to this somewhat soft division between the software and the hardware. So on the hardware side, things, as you said, like impulsivity or executive function, I think you obliquely referred to working memory, essentially, which is, from my perspective, the biggest bottleneck in human performance and one that appears to be the least responsive to change. But also ways of thinking about emotional regulation and decision-making criteria. I'm much more familiar with the physiology side. The biohacking I do is on the brain, not the mind, largely. What are you seeing as some interesting ways that we can get into cognitive change?
Mm-hmm. So the
Or psychological.
brain-mind question,
Yeah.
right, is at the core of the philosophy of neuroscience, the philosophy of mind, the philosophy of science itself, right? Because the brain-mind gets into the brain physics and the question of what is consciousness, what is physics, how do they interact, is there bidirectional causation? Beyond the scope of what we're probably going to dive into here, but is definitely at the core of what's informing the work we do. Because how in any model of philosophy of mind, however we address this, it's clear that what's happening physiologically is affecting one's subjective experience, and what's happening in one's subjective experience is being mirrored on, or affecting the physiology side.
Yeah.
And so we can obviously modify brain chemistry. The whole field of psychiatry is focused on this, right? Psychoneuropharmacology, and not just pharmacology, but neurotech in general.
Sure, sure.
To affect cognitive and psychological predispositions and capacities. We can also do practices that are involving one's direction of their own attention and subjective experience, whether we're talking about cognitive behavioral therapy, right, CBT, DBT, other psychotherapeutic processes, or even what we call more kind of mindfulness processes of proprioception, paying attention to various sensations in the body, parts of the body, and watch the changes, as I'm sure you've done a lot of, on physiology, EEG processes, and then watch the capacity for neuroplastic changes in the connectome with enough time and input in there. So it's not only that the division between hardware and software is soft, it's they are both co-evolving all the time.
And interdependent and changing each other, as you alluded to.
Yeah.
Yeah, I mean, I have to say I'm a reductionist in this space a little bit. So for me, the mind is simply the part of the brain that we are aware of and experiencing. And I kind of don't go below that. I have somewhat of a Buddhist perspective where I don't really believe in consciousness. I believe in moments of consciousness, but not the overarching I. Like if the brain falls over, from my perspective, that's it. There is no mind outside of the corporeal boundary of the skull, so to speak, even though I know that there are non-local phenomena that we're observing now in the brain, and I'm sure you are deeper into this idea of, again, the physics affecting consciousness. I've just saw a paper last week that showed that water has some strange kind of non-local, I hate to use this word, but quantum tunneling in microtubules, apparently. Yeah. Under some conditions, it appears like water molecules have a superposition and can be in more than one place at once inside of cells.
Correct.
This is getting very quickly out of the realm of anything we fully understand. But do you think that we are getting to a place where we're starting to run up against the edge of well-understood science, and we're off in the quantum weeds, or is there something here that we're making actual progress in actionable understanding of the brain?
Both. So quantum mechanics brings us to the limit of understandability, not just what we currently understand, but the upper limits on epistemology itself.
Yeah, measurability even, yeah.
And even beyond measurability, the upper limits on ontology, right? Heisenberg's theorem doesn't just say we can't know what it is because of measurement issues. It says and it depends on which interpretation of quantum mechanics, but standard model interpretation, its fundamental nature is not yet defined independent of an observation dynamic. That subject-object interaction are co-defining at the level of quantum particles. It's a very philosophically weird thing for us to think about using the intuition that we have from traditional larger particle physics.
Yeah.
Now, we have historically kind of written that off as just super weird phenomena that happens only below atoms and then cancels itself out at the level of atoms, and so we don't have to worry about it. The topic of quantum amplification. Are there quantum phenomena that then affect the behavior of things at a mesoscopic level?
At a Newtonian physics level, or?
Right. So this is, the work of Stuart Kauffman, the work of other people at Santa Fe Institute of Complexity Science, the work of people like Stuart Hammerhoff have really shown quite clearly that quantum amplification does happen, which means that the non-deterministic, right, acausal phenomena at a quantum level are affecting macroscopic behavior at the level of brains that still follows probability distributions, but not determinism. And so this is a very interesting, right, very important weird topic, and the whole topic of microtubules and neurons in specific, and superposition dynamics and quantum information processing is one of the like kind of interesting cutting edges in the field. The work of Stuart Hamerhoff and Roger Penrose kind of opened that space up. And the work of Dr. Honorbon, there's a few people kind of working in that space. And it is only scratching at the surface of what we can claim to know well, but there's already application happening in things like transcranial ultrasound that were based on the philosophy from there that seem to be having positive results. So it's a super interesting field.
Interesting. That's wonderful. Thanks for unpacking that just a touch for us.
I would say one more thing about the Buddhist perspective, the kind of John Searle idea of that the mind is what the brain does. This is one interpretation of Buddhism, right? There are different schools of Buddhism that have very different interpretations here. Obviously, the foundational idea of what's real in Buddhism, coming from Vedanta, was that consciousness is what we actually have a stronger sense of knowability on than physics, right? Sure. And so their model was, well, I know that I'm experiencing something. There's an experiencer here. I don't know that what I'm experiencing is what I think it is, but in an almost kind of Descartes-like way, there is some witness that is witnessing changing phenomena that is prima facie real, right? So their model was reductionist in the opposite direction, right? Rather that consciousness is an emergent property of physics, which is where physicalism and science has gone. They saw the rest of the universe as either not real or an emergent property of consciousness. And that kind of idealism, physicalism divide is right at the heart of what we're figuring out when we're studying consciousness via objective methods in brain science.
But correct me if I'm wrong, but old school, early Pali Buddhists wouldn't consider consciousness a phenomena outside of momentary experience. I mean, anicca, impermanence, the nature of reality is transient. So even consciousness, I always fall back to the metaphor, the classic metaphor, ship of Theseus, the thought experiment. Here's a model ship. If I replace one plank, is it the same ship? How about two? How about three? At what point is this capital I self the same if every 7 or 8 years all the molecules in my body are completely different and have been replaced? This is where it fundamentally breaks down for me personally in terms of consciousness. But would the Vedantic approach say that there is a cohesive sense of consciousness, or is it an emergent property of just having a meat suit?
So Sanskrit has a lot more words that have a lot more specificity in their definition than just consciousness, self-awareness. And they're actually very key distinctions in their philosophic system. Okay. So, and again, there are different interpretations in these systems, but the Buddhists traditionally say that the foundation of reality is neither self nor non-self, because that distinction doesn't exist at that level. That the rational distinction of the concept of self other than self is more superficial than the foundation of reality, right? It's ontologically less primary. Okay. So the idea that it's non-self or the idea that it's self are inadequate. So what we think of as self is self other than self-division, right? They talk about a foundational oneness beyond division. It would be neither of those concepts, right? Not self nor non-self. That's different than the traditional way that is spoken about in Vedanta, which is that at the foundation of all of it, there is consciousness with a capital C that is different than self, right? That can, which is basically, if you think about it almost in terms of a unified field of physics as a field of potentiality for dynamics to occur, quantum foam to emerge from, etc., that there is reference happening, but it's reference within the only thing there is, so there's self-reference, and that the foundation of what we think of as self-referentiality happens at the level of unified field.
Interesting.
Now, I'm not saying this is what I think, but this is some of the kind of interpretations there. I will say there are real problems with most of the models of physicalism. There are real problems with these models, and this is why these are unsolved, famous problems in philosophy. And you even see, like, you'll see a couple physicalists, like the classic debate that Sam Harris and Dan Dennett had after Sam wrote his book on free will, was that Dan fundamentally said consciousness isn't real, right? He's a radical eliminativist. It's an illusion, but free will is real. And Sam said consciousness is fundamentally real, an emergent property of brain, but free will isn't real.
Okay.
This is a core disagreement on the most foundational concepts of existentialism, of what actually is, both being physicalists and having the same kind of critical thinking background, agreeing on a lot of other things. So it's part of why these have been so hard is they're beyond our current tools of knowing, our epistemologic tools. When we do science, we are studying third-person things. That's what we can do.
Yeah.
So when we try and study consciousness, which is first person, by looking at the third-person correlates, we're actually doing a category mistake by assuming that they're the same thing. Also, when we assume causation, when we get to the level of things that are for sure, via Bell's theorem, acausal, our intuitions get off, right? And so these are fascinating and tricky areas. What we can say at the level of what's probably useful for people right now is that we can do things with our own subjective experience of self. So what we focus on, what we put our attention on, and the meaning we give to things that has a real effect on brain and physiology. And we can do things to our physiology that are not obviously utilizing our subjectivity that will affect our subjectivity. And there can be recursive effects between subjective and objective that can either, depending upon how you do them, have the potential of being virtuous cycles in more adaptive evolutionary directions or vicious cycles. And so learning how to use both the conscious direction of our thought, awareness, attention, and what we do with our physiology in mutually reinforcing adaptive ways is, I think, what we're interested in here.
Oh, wow. It's quite heady stuff, no pun intended. So, Dan, you sound like a philosophy guy here. Do you have a philosophy background?
Yeah.
Yeah? Tell us about that. What is your journey been there?
So I was homeschooled growing up,
Okay.
and all the sciences and all the philosophic traditions were what I was fascinated by. And so our particular homeschool didn't have curriculum, so I just got to study what I wanted. So that was interdisciplinary science, system science, and the various philosophic traditions, because the impulse to study science was the impulse to understand the nature of the reality we live in better, which is a philosophic impulse, right? Science is a method of knowing that correlates to a particular philosophic system, right? Philosophic system usually of logical positivism, or the idea that reality exists objectively, objective stuff is real, we can measure it, get the same results. So science is a subset of philosophy. It's a particularly useful, meaningful one. It doesn't happen to be an exhaustive one of all things that are meaningful. And so I fortunately got to study many different Eastern traditions and Western traditions, and my early and then deeply, and my kind of method of understanding any new discipline is I like to start by going to the edge of what the hard problems that are not understood and are believed maybe unsolvable, and then understand the range of opinions on that and why, and then go back and understand the core axioms of the field in light of recognizing where they might actually have limits. Oh,
interesting. All right, so with that perspective, with this lens into you, what are the hard problems you bump up against and enjoy bumping up against in the biohacker, neurohacker world? What are the growth edges? I mean, I see people acquiring tools and technologies and ways of modifying their physiology and their minds constantly, and I provide some of those tools. A lot of the time we're operating in a space we really don't fully understand what we're doing. There's somewhere between art and science.
Right.
And I'm sure half the things that biohackers do are completely irrelevant, and a certain percentage is probably working counter to what they actually want to do. What do you find the hard problems are in neurohacking or biohacking?
So neurohacking, biohacking, and what the hard problems are in medicine, and we kind of looking at that as medicine moving from dysfunction to function. Neurohacking, biohacking, generally thinking of it as trying to enhance function beyond previous baseline. We think of that as one gradient. Some of the hard problems that are not like philosophically hard problems in terms of maybe unsolvability or epistemic limits, but like the holy grails of the space.
Yeah.
One of them has to do with complexity.
Okay.
And so when we're trying to look at what's going on for an individual person, say we're trying to look at addressing anxiety for someone, is their anxiety primarily physiogenic or psychogenic? And what causes in each of those? If we just look at physiologic causes, we see a whole good body of work on the ability for microbial imbalances in the gut to cause anxiety. Anxiety predispositions because of decreasing the total amount of GABA produced in the gut or serotonin produced in the gut or inflammation on the enteric nervous system or whatever, right? So if someone went traveling in the third world, got a parasite, microbiome got off, has never re-stabilized afterwards, that could be a tier 1 cause of anxiety that no amount of nootropics or CBT or DBT or anything would address, right?
Yeah.
Or if they had minor head trauma where the CAT scan or the MRI didn't show anything, but maybe a QEEG would, or maybe a SPECT scan would, because there's functional firing patterns that went off. How we're going to address that? That might require neurofeedback. That might require neurogenic chemistry, right? That's going to be totally different again. If they were exposed to mold or other forms of excitotoxins, that can cause anxiety. So there can be genetic predispositions, and then we can continue to populate. There can be methylation disorders, right? There can be thousands of different things, and then the confluence of those things, right? And then if we're looking at the psychogenic side of it, we're saying someone who had anxiety since childhood because of kind of attachment, early childhood attachment stuff with parents versus only after a very acute trauma, PTSD-like trauma. They're different psychologically, they're different neurologically, and there are different best practices and therapies to address all these things. And for one particular person's anxiety, we might be looking at some confluence of some number of these factors, right, where there was a causal cascade. And then that person with anxiety maybe also has a sleep issue or not, or maybe also has some autoimmunity. Or so as we're trying to help them, how do we factor all that?
Yeah, certainly.
Complexity and personalization.
Now, is this possible? I mean, I work with brains every day, and I am humbled every day by how little I actually understand. And my strategy for dealing with that is, Maslow, to a man with a hammer, every problem's a nail. My hammer is neurofeedback and meditation, and to some extent nootropics. But I view the brain as a regulatory machine, and then when I do a QEEG and see something off and it matches symptoms, it's a little bit more skilled than being a mechanic, perhaps. But it's that approach. It's the let me go reach it and tweak this and see what happens. I'm working on integrating lots of different information systems so that I can, do visualization, do big data, do a better sense of what's happening. But even that will have a fraction of the degree of things you're talking about.
Right.
Is it a solvable problem? Can we actually bring in personalized medicine, if you will, personalized psychology, track data this way? I mean, is this being done? Can we do it? I think we're getting enough information about the individual data points. You can do a methylation analysis. You can do a theta-beta ratio. You can do, a blood flow imaging or something. But these measurement tools are limited by the tool space that they are using. QEEG gives me one thing. Right. It gives me less than half the EEG, only the dipoles that are at right angles to the skull. And it's a 10,000 foot population average of averaged EEG across several minutes. So you're missing states completely, only emphasizing traits. And this, 30 or 40 big features in the QEEG that I look at and that I operate on in terms of intervening. But I default back to that because I can't do everything, because I can't hold everything in my mind, and I can't ask everyone all the right questions to tease out what might be going on, because I just don't understand the brain fully. I mean, as you say, probably none of us do. Are we getting to the place where we're going to be able to aggregate and analyze and extract meaning from this complexity? Or is the complexity going to obscure our ability to know what's real and know what's important?
Yeah, I do believe we are starting in the next few years.
Okay.
And having an exponential curve.
So this is a Kurzweilian prediction here?
of sorts, in a different direction than I think much of what we hear about what is going to happen with brains from singularity.
Okay.
But as you said, we can't hold it. You can't hold it all in your brain. That's true.
Yeah.
The total amount of information exceeds our conscious processing by a lot, right?
Because of working memory limits, mostly, right?
Yeah.
There's no storage limit in the brain, as far as we can tell.
But there is a working memory limit for your ability to consciously try to make sense of not just how many different metrics, but the relationships between those metrics, right? The combinatorial relationships. So say we start looking at the genome, most things aren't affected by SNPs, right? By one SNP. There's a very few things that are. Mostly we're looking at dynamics, combinatorial dynamics across tens or hundreds of thousands
downstream
of SNPs.
effects, essentially.
Right, but that's a lot when you look at 3 billion base pairs. Right?
Yeah.
And then we have to deal with the fact that that doesn't tell us which ones are actually coding, right? We have to look at the epigenome for that, which is not something we do well right now. So we actually have to look at the transcriptome or exome, proteome, which is all stuff that is emerging but hard. And
that's just the human genes, which is not actually the majority of the genes we carry around, or actually aren't human, right? So
if you think about it this way, right? When you were saying the brain is a regulatory system, it's a top-down regulatory system, right? The bottom-up regulatory system is the code layer. The genomics, the microbiomics, the viromics, right? They are creating a distributed bottom-up regulation of individual cell function, right? And protein coding.
Sure.
That bottom-up regulatory capacity is what led to the evolution of top-down regulatory capacities that get to control larger groups of cells and tissues working together in coordination. The feedback relationships between the bottom-up and the top-down regulatory systems and all the dynamics in between is where what I think we're starting to do is map the human as a cybernetic organism, right, as a regulatory organism, apply complex adaptive system science and kind of systems modeling to understanding that better. And it is what in computer science is called an NP-complete issue. It's an uncomputable issue. There's an uncomputable amount of information. So we're not just going to brute force big data and machine learning and figure it all out.
Well, it's a chaotic system. We do not have infinite precision. Therefore, any model that steps into time far at all diverges from the chaotic system. And
so, yes, it's chaotic, meaning there's some fundamental unpredictability. There are measurement limits, and then there is uncomputable complexity. And so what that means is, rather than just depend on brute force computation, we have to understand the dynamics of causation in a complex system better so we can compute the things that actually seem like they would make sense to happen, right? That's the modeling part. I think the modeling part is key, and that's at Neurohacker what we're really focused on is taking models like cybernetics, right, like complex adaptive system science, like information theory, and putting what we understand from human biology and medicine into those more complex models to understand dynamics better, right, complex dynamics. And getting to the place where we can start to aggregate tremendous amounts of data there, and data that has progressively better sensitivity and specificity, and then be able to process that data where, right now, for the most part, when we look at a biometric, we look at someone's hemoglobin or their vitamin D or whatever, we're looking at it in relationship to a reference range.
Sure.
But when we look at someone has a kind of dynamic homeostasis, right? I actually really like your word, homeodynamics. It's a better word because the stasis is nonsense, as you mentioned.
Sorry, a knee-jerk response when I hear the word homeostasis.
Sure.
But life is not stasis.
We have these homeodynamics. And then thriving health has to do with the homeodynamic capacity and resilience across all of those homeodynamic axes, right? Aging is decreased homeodynamic capacity across some of the axes.
And does that mean decreased range of variability, essentially?
Decreased capacity to have a stressor, right? Some things that's trying to create deviation from homeostasis and the ability to stay within the homeodynamic range. So then which means less resilience.
So to be concrete, things like insulin or cortisol, let's say insulin rises when you consume sugar.
Right.
When, it's a signaling molecule, cells suck up the glucose, insulin goes back down. If you chronically perturb the insulin system to the top of its range, eventually it stops varying.
and we call that type 2 diabetes. And on the way there, the kind of syndrome X dynamics where fasting insulin levels raise, you get insulin resistance at the level of cells. Now you take sugar in and your blood sugar is going to go further out of balance for longer, right? Causing more effect on other systems that are affected by blood sugar, so more than pathophysiology. So we're defining here aging is not disease, because disease we'd actually say is the deviation from homeostatic range or homeodynamic range, where some metric actually goes out of effective range, and then you get a pathophysiologic cascade, right?
Yep.
So aging is not that, it's the increased susceptibility for that. So it's increased susceptibility for disease, because someone could have all of their markers within homeostatic state range, but more sensitive to them being able to go out of range from whatever stressors.
So they're less liable to sit in the healthy basin of the phase space, so to speak.
Right.
Okay. All right.
And so what we're interested in here is how do we, where someone already has disease dynamics going on, how do we identify specifically what caused deviation from homeostasis on which dynamics, what was the causal cascade that happened, and how do we specifically reverse it? And like we mentioned with the anxiety, are we chelating neurotoxins, or are we fixing the gut-brain axis, or those are very different things. So it requires specific addressing of what the causal cascade was.
So this is not, let's say, go back to insulin, the insulin insensitivity that cells experience after high levels of insulin, that's not the disease itself. That is the failure of the dynamic range.
Correct.
And when we call these diseases things like diabetes and Alzheimer's and other things because of the failure.
Now, there are some people who get type 2 diabetes who did not consume too much carbohydrates relative to what they burn, but they are deficient in chromium or vanadium that are necessary to actually have insulin process at receptors. So there are other dynamics that can go on, which is why we actually have to understand what is the entire causal phase space of what can cause an imbalance, all the things that could be involved. And this is what we've sucked at medicine so far, is dealing with complex causation.
Yeah.
Acute causation, straightforward, right? So injury, pretty straightforward, and so we're going to be able to address that in a clear way. But where the causation is either delayed in time, right? So something happened and it led to a slow deviation from homeodynamics over the course of years or decades, it's hard to assess what it was.
Yeah.
Or where it's multifactorial. There's many different things going on, and where it's a combination of some multifactorial set that's different for different people. So I don't think MS is a disease. I think it is, and I don't think Alzheimer's is a disease or anxiety. I think they are conditions where some cluster of symptoms and biomarkers come together where we call it that, but the actual causal etiology going into it can be radically different from one person to the next.
So more of a syndrome, less of a disease, a cluster of symptoms that may have multiple causal features. Interesting. I saw a study out of UCLA a couple weeks ago that suggests Alzheimer's insulin insensitivity, if you will, can be reduced simply through behavioral mechanisms. They took a bunch of people off of all the meds, off of anything, and instead of doing a specific intervention, they said, let's do lifestyle things. And did, paleo diets and exercise, and lo and behold, symptomatic Alzheimer's individuals showed recovery of some function.
Totally.
This is fairly magical things. There was a study out a couple weeks ago showing that even in people with type 2 and type 1 diabetes who have no beta islet cells essentially anymore in their pancreas producing insulin, short period of fasting, I forget, was it 12 or 24 hours, a very short period, seems to cause a redifferentiation of non-beta islet cells into beta islet cells to produce insulin.
Right.
That flies in the face of what we thought of in the disease model of diabetes, where it's either autoimmune or it's toxic from the sugar essentially that kills insulin-producing cells. Once they're gone, they're gone. That does not appear to be accurate. Is this the kind of thing that you're digging into?
It's the same thing with the idea that we don't produce new neurons, right? That was an old idea.
It's true.
And then we realized neurogenesis happens and it can be upregulated.
And then it was only in 3 places, and now it's pretty much everywhere you look in the brain, we're finding new pluripotent stem cells.
And so can we increase pluripotent stem cell production and their differentiation throughout the connectome, and can we increase neuroprotection and synaptogenesis? And we're learning a lot about how that works. When you have a system that generated itself, it was a self-generating system, the idea that it just could not generate those tissues that it originally generated, again, doesn't make that much sense. There was obviously a capacity to do it, and then the capacity decreases or turns off for some reasons. Those then likely are modulatable to turn on again. So
Sure.
when we think about life extension, how do we increase progenitor stem cells?
Mm-hmm.
How do we increase the rate of purging senescent structures?
Mm-hmm. Mm-hmm.
How do we protect cells from senescence?
Mm-hmm.
These are all things that happen already,
Sure.
but they can start happening at suboptimal levels for a lot of
Right.
reasons. We can support them happening at optimal levels and maybe even beyond previous genetic optimality.
Right. Just to give a discrete example, I'm a gerontologist, teach courses in aging. There's a term in aging called antagonistic pleiotropy. The idea that a mechanism that is healthy at one point in life is harmful at another point in life. And the telomeres, the shortening end caps that prevent replication forever, when you're young, prevents cancer from running away with your cells.
Right.
When you're old, keeps fibroblasts and your collagen from cleaning themselves up, and they become homes for a pro-cancer environment, basically.
Yep.
So it's this kind of thing where you're identifying where the natural arc of development may not be optimal for long-term performance and turning these things back on and controlling it. I mean, from the point of view of telomeres, for a long time that was, of course, the holy grail in antisenescence, and now we realize if we could give everyone a pill to lengthen telomeres, ridiculously, it would probably just cause huge amounts of cancer. So we can't simply reach in and turn one thing on. I mean, this is something I struggle with in neurofeedback. It's not reaching in and dialing up and down different neurotransmitters or different, brainwave ratios. When I perturb a system, the system reorganizes, and I'm never quite sure how it's going to reorganize. And this is, a little frustrating sometimes.
Well, so if we think of it as increasing system resilience, right, homeodynamic capacity, because it is a self-organizing system and the complexity is well beyond what we're going to understand in a momentary view, right? We're never going to factor all of the dynamics happening, probably even in one cell. But we can understand the dynamics that are involved in some of the key ones in its own regulatory dynamics and how we can increase its regulatory capacity. And so, in general, do we see things like redox signaling decreasing in efficiency in cells? Yes, right? So this is why all the nicotinamide riboside stuff has been so exciting. Is if you can upregulate the NAD plus NADH ratio, there's a lot of cool things that happen.
Yep.
Do we see ATP decreasing inside of cells? Yes. Do all the things that cells do need those chemicals? Sure.
Yeah.
So if we can support mitochondrial biogenesis,
Yep.
if we can support ATP production efficiency and Krebs cycle upregulation,
Yep.
if we can support protection of the mitochondria so they don't become senescent, right?
Yep.
These are key things that, what exactly is that going to do? Well, it's going to help the complex dynamics of everything that the cells are doing happen better. And so I think those are one of the key things we were saying earlier, there are specific sources of pathology, right? Causes of deviation from homeostasis that we want to identify specifically and reverse.
Yep.
Pathogens, toxins, deficiencies, etc. Then there are general system dynamics that support system resilience, and we want to support those even though the effects of that are going to be general, increased well-being across systems. So EEG regulation is going to produce, how much is it going to affect a particular gastrointestinal dynamic? Well, it depends on what all the causal dynamics are.
Yeah.
But it should move it in the right direction to the degree that it's creating better sympathetic, parasympathetic, ratio dynamics, etc.
Yeah.
So we want to, in general, support the homeostatic processes that are fundamental and get better at diagnosing individual sources of pathology and reversing them.
This is great. I mean, this actually ties into how I often frame neurofeedback for people, and they say, oh, I want to do this. And I'll say, well, we're probably going to give you more resources in all of the regulatory domains of sleep, stress, and attention. And what that means is resilience.
Right.
And we can probably reach in and do more specific things for you. But let's see what happens first when we bring the resilience way up and get you sleeping like a rock at will and being creative and flexible. Let's do that for the first few weeks. And then we can go in and try to target the thing you think you care about.
Right.
And usually the thing that they really want to work on sorts itself out along the way towards just building everything.
The complexity of the interconnectedness of everything is, again, why specialties have failed at complex illnesses.
Yeah.
But it's also so fascinating because, we can look at a structural issue, right? Like a postural issue or osteoarthritis that's causing continuous inflammation, where then the inflammatory molecules, right, cytokines, can cross the blood-brain barrier, cause neural inflammation and damage to neural circuits.
Yep.
Also, where the continuous pain dynamic is causing sympathetic feedback into the brain, which then is going to cause effects on all the things the brain is regulating from a top-down perspective.
Right.
And what needed fixed was a structural issue in a knee.
Right.
Right? And or mold in the environment, or a runaway process of dysfunctional information processing in the brain from a particular psychologic meaning-making pattern, right? So can structural issues in joints, or psychological patterns of focus and meaning-making, or things going on in the gut, or affect any other system in the body? Yes. This is what's fascinating, and it's why trying to separate neurology and gastroenterology and oncology have just doesn't
futile,
work, right? And so now it's how do we synthesize what we understand about the parts to understand what happens for whole systems and what happens across systems.
So now you're doing this at the Neurohacker Collective with this idea of bringing in different aggregate data types and modeling and trying to figure out what is the meaningful inflection points for these models where, where's change happening. That's very, high level. And those are the kind of projects that frustrate PhD students for, 20, 30 years.
Yeah.
I think it's great. I'm incredibly noble pursuit to answer those big questions. I also know you guys are doing something that's a little bit more, okay, here's some things we can actually do. There's a product you've produced called Qualia, which is a nootropics. Is it in the nootropic space? Okay.
Yeah, sure.
Do you consider it a nootropic, or is it more than that? Is that a good frame for it, or is that too limiting?
I think that's a fine frame. As you know, the term nootropic is a little bit loosely defined in terms of how it's generally used.
How do you define it?
Well, I would in general start by making the distinctions between brain nutrient, nootropic, and smart drug, which are commonly used kind of in relationship to each other, but it's worth distinguishing. So brain nutrient means something that you'd normally get from a dietary source that's critical to some part of neurologic function that can often be at suboptimal levels.
Precursors like tyrosine.
All your amino acids, fatty acids, vitamins, minerals that are part of neurodynamics. And when we talk about medical deficiency, we're talking about a level at which acute pathology is happening. Below that level, there's a pretty huge range between medical deficiency and optimality, right? And so we can call that subclinical deficiency or suboptimality. And so there's heaps of brain nutrients that, depending upon what kind of test we do, we see in suboptimal levels all the time, right?
Okay.
Vitamin D is a popular one.
Sure, yeah. Even in Southern California.
Even in Southern California. And because it's not at a level for, rickets.
Right.
Someone has a, 30 vitamin D. Traditional medical process hasn't addressed that, but when we, have deeper insight about where optimality occurs, it's a far way away, which is why vitamin D supplementation is meaningful. Same would be true with omega-3 or tyrosine or et cetera. Right? So brain nutrients that are either hard to source adequately in diet or where modern lifestyle has us use them faster. So if we're talking about higher stress lives where B vitamins are going to process faster or whatever, then those are meaningful.
Sure. Or if you're a vegan and you aren't eating anything that has B vitamins in it.
So diet, any kind of dietary limitation is one of the things to address. Nootropics, starting with, defining Racetam as that field is some chemical that can increase some aspect of cognitive function beyond baseline without meaningfully negative side effects.
Thank you for including that last piece, the original definition, essentially. This is one of the axes I love to grind. I'm all over the nootropic forums and things, and I can't tell you the number of times I have to resist reaching through the computer and throttling some kid who thinks that modafinil is a nootropic.
Yeah.
Nothing with a significant side effect should be considered, and I'm guessing you have the same perspective I do. If your performance is already relatively good, why would you risk side effects for small incremental improvements, baseline improvements? If you're trying to remedy a deficit, then okay, maybe you need to risk some things to get a problem sorted out. But I don't understand the incredible marketing and consumer push to seek for all of these drugs and compounds that some of them have very, very significant side effects on the off chance that they're going to be designed for your sort of neurochemistry and give you that little boost. I don't understand the philosophy, if you will, behind that. This idea that you can reach for something that might not be unilaterally good, just in case it might. That seems very non-nootropic, to me, so to speak.
So the topic of risk-benefit ratio is core to Western medicine, right? And it's partly why we only have a disease model and we don't have an optimization model, is because in the disease model, there is risk to not treating the thing, right? There's pain problem. So some risk of a treatment seems warranted. And you have to make sure that the risk makes sense to the possible benefit. If people are already generally healthy, and this is also why longevity research hasn't, had a lot of support until recently, or any kind of optimization, which is why it's been left to biohackers, is how much risk can we justify for how much benefit beyond baseline?
Right.
It's actually a really deep question, and it's a question that should be answered individually within a range that is reasonable for the field as a whole to pursue. Now, I think bodybuilding and steroids is a classic example of this, right?
Okay.
So can people perform in fundamentally increased ways with anabolic steroids that they couldn't otherwise? Obviously.
Right.
We know this.
Otherwise, you wouldn't ban them in sports.
And we're the people who are really pioneering this, risking their health, and if many of them experienced the downsides of that already, totally.
Yeah.
And for them, at least, knowing that quite clearly, for many of them it was worth it because that's what they wanted to do, right? Like the same reason anyone would do anything that was not a smart longevity decision for what they wanted to do in the moment. And then the field of steroids itself evolved from a lot of that experimentation to where some of the SARMs today have, compared to the early anabolics, have radically more benefit for much less risk.
Yep.
Partly evolved by kind of the citizen science happening in that space that just for ethical reasons couldn't happen in formal research.
Sure.
So it's a very interesting topic, right? And it is a place where citizen science is always going to be advancing the front edge. And I would say all of the psychonauts working with deep psychedelics are in the same place. And so one of the things we really like is for people who are, for whatever reason, inclined to do their own research, give them better quantified self tools and learn from that if it's outside of what we can do formal research on, and then be able to take the formal research from there.
So crowdsourcing at a very big level, essentially. Yeah. Oh, that's great.
Now, with regard to what the appropriate risk-benefit dynamics are, so you mentioned modafinil. I'd take it further. Methamphetamine definitely increases certain cognitive capacities.
And it kills the flu virus.
It has a number of positive medical potential.
Yeah.
And it has very real side effects. Yeah. And so if someone is in a combat situation and they need to stay awake a little bit longer, meth might make sense, right? Part of how those drugs were developed.
Yeah.
For general use for your midterms, it's not a good idea. Now, if we look at how much off-label Adderall and modafinil and Red Bull and whatever, right, happens for those purposes, this was one of the main reasons we decided to make Qualia, was not only are the downregulation and side effects pretty significant of most of those, but even the positives are fairly narrow, right? So if you use a presynaptic dopamine agonist, right, like Adderall, you will get increased focus, but you might actually get simultaneously decreased working memory, as we've seen on a number of studies, which is not the kind of total intelligence that we're interested in, as well as anxiety, irritability, depersonalization, all of those other dynamics. And then, of course, because it's an external override of an internal regulatory system, downregulation independence. Yep. And so what we were really interested in, and what I'm sure you've been interested in the space, was can we, understanding this system more completely, and nowhere near total completely, but more completely, right? We're not just trying to do a single molecule intervention. Can we have a much more comprehensive set of positive effects rather than a narrow set without the negative effects in real time and without downregulation? So that when someone gets off of them, they're not experiencing addiction come down, but if anything, experiencing long-term upregulation of the capacity of their system. So that's the design principle with which we approach the whole space, quality and all the products in development.
So quality's your first product then?
Yeah.
What's in it? I haven't dug into the ingredients at this point.
So brain nutrients and nootropics.
Okay.
And so as you know, when people start in the nootropic space, usually they dive into acetylcholine first.
Sure.
Right? And so racetams and some choline donors, that's like the foundation for memory augmentation, sensory nerve, motor nerve, acuity, etc. So, but which racetams you use are going to have a bunch of other differential effects. And racetam and phenylparacetam are very different creatures.
Oh, yeah.
And also, are we going to address the ability for the acetylcholine, once it's produced, to get across the synapse? Are we looking at acetylcholine esterase inhibitors? Are we making sure that the acetyl groups aren't rate limiting for the choline that's there, that people aren't getting overcholinergic? If we look at different choline donors, centrophenoxine is going to act on the central nervous system more than alpha GPC on the peripheral nervous system. If we look at the conversion of uridine to citicholine to phosphatidylcholine to alpha GPC to acetylcholine, you're also going to get different peak plasma times of when acetylcholine kicks in. So if you want to be able to have less of a spike and more of a continuous process, you might put a number of those. So we focused on, like with acetylcholine, we're looking at what is the whole acetylcholine regulatory process, and how can we address any of the rate limiting factors and make sure that where we're acting on peripheral nerves, where we're acting on central nervous system differentially more is what we want to be doing. That the kind of pharmacodynamics and kinetics of so not just where it's acting, but how long it's operating for. And those curves are things that we really look at. How much acetylcholine we're producing. So that you've also got not just acetyl donors, which is why people love Alcar, right? Acetylcarnitine. And one of the reasons, in addition to what carnitine does in the Krebs cycle, is B5 is often a rate limiting factor for the synthesis, right? The acetylation of choline. So, what are the right ratios of those things together? And then how much acetylcholine support for how much NMDA upregulation? And then where do you get rate limiting effects in terms of the total cellular energy to process more acetylcholine? And then all of that's just acetylcholine. Then we look at glutamate, and typically it's pretty common that racetams have ampakine-like properties. Many of them.
Certainly, anti-racetam does.
And Nupept, which we use.
Now, I always get confused. Nupept seems to have racetam-like properties, but not be a racetam.
That's correct.
I mean, I look at the structure and it doesn't have a pyridine ring.
That's correct.
So
it's called racetam-like and ampakine-like because of upregulating acetylcholine uptake in the NMDA complex, upregulating glutamate uptake at the AMPA complex, but it is actually not structurally either of them. But it's very interesting. It's a precursor to cycloprologlycine. It is neuroprotective. It's anti-excitotoxic because of the way that it brings excessive glutamate outside of the synapse. So it's a very interesting molecule.
And Nupep's in qualia as well?
Yeah.
Great.
Now, there are plenty of things that we would have in qualia if there was different regulatory dynamics. But, so we're working within both the general, well-tolerated space, the effective space, and the legal space.
Sure.
People microdosing LSD or psilocybin has a lot of neat effects. We can't touch that, obviously.
Right. Not yet.
Not yet. So actually that space of the appropriate legal categorization of medicines is a space that we have worked in and intend to more because it's important.
So more political, legal, and regulatory, not at the physiology, but at the body politic.
Exactly.
Interesting.
So when you look at acetaminophen being over the counter as a legacy thing and the toxicity of it compared to pot having been illegal for and still illegal in so many places for so long, it's just nonsense. Right. And we can look at the whole history of why those nonsense decisions were made, but they're not just nonsense, they're really bad for people. Because pot doesn't cause liver damage and acetaminophen does, but it addresses the same pain dynamics that people would use acetaminophen for.
Yeah, but you can put acetaminophen with opiates, and that prevents people from taking all the opiates and overdosing. In theory, that's of course the Tylenol 3 Vicodin kind of approach is to bind acetaminophen to to say, hey, it's going to kill you if you take too much, don't take too much.
And so then people take too much and get liver damage.
Right.
Yeah.
Right. So sounded like a good idea, but maybe it wasn't well thought out.
Right.
So it's been heady stuff, Daniel. Thank you so much for sharing a bit of your wisdom. Where can people find out more about you? What other projects do you have going on? How can they dig into the Danielness that we have here in front of us a little more if they have had their interest sparked?
Well, as far as the topics we're talking about here, neurohacking topics, neurohacker.com is a good place to go check it out.
Great.
Publishing more information there. And I want to say that the work that you are doing in neurofeedback and the fact that you're scaling it with quality control and with the systems that allow that to happen, that's one of the areas that if you hadn't done it, we would have eventually got into because it's critical and we think it is one of the really most meaningful neurohacks that has the least damage possibility.
Yeah, really small downsides.
And if done well, right?
Yeah, it's true.
Super high reward possibility. So I'm excited to look at if there's a way we can partner and support what you're doing.
I'm sure there is. We're both in Southern California, so we should at the very least try to work that. Great. So can folks follow you on Twitter, Instagram, LinkedIn? What's the if they want to follow you and hear you drop wisdom and see all the things you do, what's the best way to do that?
Facebook is probably best.
Facebook. All right, great. So today's guest has been Daniel Schmachtenberger of the Neurohacker Collective. We've packed more into this hour than I think most shows we've had. I'm going to have to go back and listen to myself and look up a few terms, which is great. So I rarely have to stretch myself that way. I really appreciate it. So, folks, it has been another show of Head First with Dr. Hill. Take care of your brains, and we'll see you next week.